For this lab, we recorded the motion of an object and analyzed this motion using Tracker and predicted the motion using GlowScript. The objective of this lab was to use and observe Newton's second law, which states that the force equals mass times acceleration and final velocity equals initial velocity plus net force divided by mass times change in time. And again, we used Newton's second law to determine the predicted value of motion. And for the observed value, we used an orange. After recording our motion, we put our video into Tracker, where we were able to flip through the video frame by frame, plotting position points to give us an accurate graph and data points of how and where the object is moving. So for our observation, when we did our plotting the points, we got back a graph that was increasing, positive, and going in the rightward direction. And we were also given a data table so we could get our position vector. So at t equals 0, the position vector is going to be about 0.002. And from our position vector, we're able to get our velocity vector to help us later on calculate that predicted motion using the Newton's second law equation. And I did realize a mistake after getting our predicted values and data table, and I had to come back and redo our velocity, and we can come back to that. So for GlowScript, we use to calculate, again, Newton's second law equation to get our predicted motion. So for this, we had to change a couple of equations in GlowScript just to reflect that F-net equation. So we changed ball velocity and ball position, and we also set F-net equal to 0. And this was because to keep that constant velocity, because as we saw in the tracker graph, it was a relatively straight line, meaning we have a pretty constant velocity. So for this, we're setting the F-net equal to 0 because to have that constant velocity, the final and initial velocity have to remain the same. So predictions from GlowScript. So we again got that positive increasing rightward graph, which was perfect. And then this was where I did realize the mistake that had occurred. So when we got back our data table, I noticed that the time for GlowScript and the time for Tracker did not match. So it wouldn't be accurate at all to compare those two data positions because the timing was not quite the same. So to fix this, I took the end time of 0.567 and divided by 17 because from t equals 0 to t equals 0.567, there's 17 steps from that starting point to the ending. And that gave us a much more accurate time, which we then could recalculate the velocity to be more accurate for our GlowScript graphs. So for the comparison, after finding our two graphs and two data tables, we combined those to compare the two of them. So now that our times were right, we were able to compare right at each specific time what the graphs were doing. So for the observed position, we can see that it goes in that constant velocity and it's relatively straight throughout. However, we see that for our predicted position values, where we definitely had that constant velocity, it is extremely straight and becomes almost an over prediction for the observed because the observed seems to go down as time continues and it kind of deviates from that really constant velocity. And we can also see that on our data table as at the beginning it's relatively close and then towards the end it begins to deviate by about like 0.1. So what if and what does this mean? So if we change the orientation of the axes, the graph will have the same slope except it will be going in the negative direction. So it'll be a decreasing graph. And this would symbolize an object that's instead going right to left instead of left to right. And it would also have a negative velocity opposed to a positive one. And to find the exact number of pushes or pulls on an object, it would be very difficult because with that velocity being constant, as we saw, F-net would be 0. And also in this equation, force equals mass times acceleration. Acceleration would be 0 with that constant velocity, and it would give us an overall force of 0. So critiques and conclusions. So obviously, the predicted motion was an overestimate of the actual motion. And for myself, I may want to take a video at a different angle and make sure the orange is really centered. I did happen to notice the mistake with the time, so I was able to fix that and compare them successfully. And through this lab, we were really able to understand that through Newton's second law, we can predict the motion of an object. However, as time increases, the observed and predicted tend to vary due to some outside forces that could affect it.